Alright, if you're watching this video, it's because you were absent on the day we did energy conservation, so we'll do the 4 practice problems from the PowerPoint. Let's go. Gabby has a mass of 50 kilograms and slides down an unusual slide with a height of 2 meters. What is her velocity just before she hits the ground? Friction is negligible, so it doesn't really matter what the slide looks like. According to energy conservation, all the energy she has in the beginning, energy at the top of the slide, will equal the total energy she has at the bottom of the slide, as long as friction is negligible. So at the top, she's not moving, so she only has potential energy. At the bottom, she's sliding down and she's at the ground, so she no longer has potential energy. All of this potential energy becomes kinetic energy, the energy of motion. So we can say that the potential energy at the top of the slide should equal the kinetic energy at the bottom. PE at the top is mgh, that's the equation for potential energy, should equal the equation for kinetic energy, 1/2 mv squared. Note the masses cancel, so we actually didn't even need her mass. G is 9.81 meters per second squared, that's the acceleration of gravity, times a height of 2 meters is equal to 1/2 times v squared. We're looking for a velocity, so I'm going to multiply both sides of the equation by 2. This cancels the 1/2. So 2 times 9.81 times 2, that's 4 times 9.81 is equal to v squared. I can then take the square root. This will give me velocity. Velocity is equal to the square root of 4 times 9.81. I'll grab my Wabbit emulator. 4 times, I'll do the square root second, x squared. I can also raise this to the 1/2, 4 times 9.81. And this gives me a velocity, a positive value of 6.26 meters per second. I can choose the negative or positive solution, I don't care. And there we go. That was practice number 1. Practice number 2. Lavender is driving his first car. He travels at 20 meters per second. The car has a mass of 950 kilograms. Suddenly, he must hit the brakes to avoid a Houston pothole. If the brakes exert a force of negative 2,000 newtons, how far will he travel before coming to a stop? The reason the force is negative is because the brakes cause this forward velocity that the car has to slow down. So the brakes exert a force in this direction while the car's velocity is going like that. That causes the speed to diminish and the car can come to a stop. So that's why I have this direction of negative 2,000 newtons. How far will he go before coming to a stop? The brakes do work. This is work done by the brakes. They exert a force over a certain distance, and according to the work energy theorem, the work will equal the change in kinetic energy of the car. We'll expand on this now. Work of the brakes has the equation the force applied by the brakes times the distance or the displacement of the car as that force is being applied times cosine theta. Because I told you that the force is negative, we're not going to have to worry about angles right here. I'm just going to leave that cosine theta off. I've already given you this negative value. Reason being, cosine of 180 degrees, the car is being displaced to the right, let's say. The force is applied to the left. This is an angle of 180 degrees. Cosine of 180 degrees is -1, just to show you. Oops, I'm in radians. So again, cosine 180 is -1. That is the angle between the applied force and the displacement. But because -1 E0, that's just -1. But because I've already given you this negative value, we don't have to plug it back in. Equals a change in the kinetic energy. That's KE final minus KE initial. The car comes to a stop. If it comes to a stop, the final kinetic energy before he started applying or after he applied the brakes is 0. The initial kinetic energy is how much energy the car had before he started applying the brakes. We're looking for how far he travels, so we're looking for this S, which we have right here. So let's go ahead and plug in negative 2,000 newtons. This is the force exerted by the brakes times the displacement of the car is equal to negative, because that's 0 minus initial kinetic energy, negative 1/2 times the mass of the car times the initial velocity of the car squared. The displacement of the car should be equal to negative 1/2 times the mass of the car is 950 times 20 meters per second squared divided by negative 2,000. I'll grab the wabbit. And if you go alpha y equals, enter, you can pull up a fraction, negative 1/2 times 950 times 20 squared divided by negative 2,000. This is 95 meters. So that's how far it takes. 9.5 E1, that's 95 meters. Okay, next up. That's how far it takes to come to a stop. Maya supports a 2.5 kilogram physics crate as shown and walks 10 meters down the hallway. How much work does she do to the crate? I don't mean when she lifts it up. I mean in the action right here where she's applying a force in this direction to support the weight. So this is her force applied, and that's to support the weight of the box. She causes the box to be displaced in this direction. I know work is F dot S or Fs cosine theta. The angle between the force applied and the displacement of the box is 90 degrees. So work would be Fs times cosine of 90 degrees. Cosine of 90 is 0, and I'll show it to you here. Cosine 90, 0. So even though her muscles might get tired, if she doesn't raise or lower the box, if she just carries the box perfectly level and is walking sideways, she actually does no work to the box. So the work is 0 joules. Work is a change in energy. She's walking at a constant speed. She's not lifting or lowering the box, not increasing its potential energy or decreasing it. So she does no work. Question 4. Diego rides his bike at a certain speed. If he triples his speed, what happens to his kinetic energy? So let's see this. Kinetic energy has the equation 1/2 mv squared. What happens to this new kinetic energy if we triple the speed? Tripling the speed, 3 times v, I keep that in parentheses and then I square it. This would make the equation look like this. 1/2 times m times 9, because 3 squared is 9, times v squared. I can put this 9 out to the front. 9 times 1/2 times m times v squared. So if I compare this equation to this equation, I can see they're almost exactly the same. I still have 1/2 times m times v squared, but I'm also multiplying by 9. So if he triples his speed, he increases his kinetic energy 9 times. So 9 times kb. That's all that I have for you guys. Thanks for watching and study well.